A thermometer reading 81 degrees Fahrenheit is placed inside a cold storage room with a constant temperature of 33 degrees Fahrenheit. If the thermometer reads 72 degrees Fahrenheit in 13 minutes, how long before it reaches 60 degrees Fahrenheit, assuming the cooling follows Newton's law of cooling? This is a very interesting problem. Now, before I begin to do anything, I need to know the equation that models the behavior of all the things that has been explained here. Now, they've helped us by telling us that the cooling here follows the one depicted by Newton, that is the Newton's law of cooling. So I'm going to write that down. So this is the model we are using. We are using U of t, that is U of t equals t plus u naught minus t e to the power kt. This is what we are using. Now, what does all these things, what do they represent? Now, the T you have here represents the constant temperature, that is the temperature of the environment. Now, the U naught you have here, just mere looking at the naught, the zero here, the zero means the temperature at time t equals 0. That is why you have a 0 here. So U naught, anytime you see U naught, it implies the initial temperature. So the T again is the temperature of the environment, while the T here is the time. So you observe that here we are not given the constant of proportionality. Now, before I begin to do anything, so my aim is I want to look for the question that I'm told to find. It says, if the temperature reads 72 degrees Fahrenheit in 13 minutes, how long before it reaches 60 degrees Fahrenheit? So I'm going to write that down. I need to know the question. So it's going to help me in knowing the direction to take. So how long? That means find t. How long means find t before it reaches 60 degrees Fahrenheit. To find t when the temperature, so U here, not t, so t is constant, so U is representing temperature. So find t when U equals 60 degrees Fahrenheit. So this is what we want to find. So we're going to circle that. We'll come back to this later. Before I can use this equation here to answer this question below, I need to find the value of k. So normally in the questions, you're not always given the constant of proportionality, but you're expected to use the information you're given to find the constant of proportionality. Alright, let me go ahead and find the constant of proportionality based on the information I'm given. The first information I'm given here is a thermometer reads 81 degrees Fahrenheit. A thermometer reading 81 degrees Fahrenheit. So that's to tell us that this is the initial temperature before it was placed inside the cold storage room. So my U naught equals 81 degrees Fahrenheit. So it was placed inside a cold storage room that has a constant temperature of 33 degrees Fahrenheit. So that is the temperature, the constant temperature of the environment is 33 degrees Fahrenheit. So it says, if the thermometer reads 72 degrees Fahrenheit in 13 minutes, that is when t equals 13 minutes, we're told that U of t, that's the temperature of the thermometer, equals 72. So how long will it take before it reaches 60 degrees Fahrenheit? Now, before I come there, I want to use this whole information here to find k. So I'm going to begin substituting them. So let's bring this here. So my U of t is 72. I write that down. 72 equals, now my t here is 33. I'll write that down. Then plus U naught. So my U naught is 81. So this is going to be 81 minus t. So the t we have is 33. So again, this is 33. Then we have e to the power k. So we have e to the power k. So this is what we want to find. And then what is our t? So the time is 13 minutes. So times 13. So now let's begin finding k. So to find k, what I'm going to do is I'm going to begin to reduce this step by step. So we can bring this here. So this becomes 72 negative 33 equals, so you have 81 minus 33. Now 81 minus 33 is going to give you 48. E to the power k times 13 is 13k. So we can write it the other way around by saying 48 e to the power 13k equals, so 72 minus 33 is going to give us 39. Now to find k, the first barrier is 48. So to find k, I need to divide both sides by 48. By 48, by 48. So this goes off. So what you have is e to the power 13k equals 39 divided by 48. Now if you use your calculator to confirm this, what you should obtain is 0.8125. So I believe you know how to calculate that. So to find k, like we have been doing before, we take the natural logarithm of both sides. So you have the ln of e to the power 13k equals the ln of 0.8125. So when you do this, so your k comes here, so you have k, the ln of, sorry, I said k, 13k, sorry, 13k, the ln of e, so this is the ln of e, equals the ln of 0.8125. so the ln of e is 1, so what you're left with there is 13k equals the ln of 0.8125. So since what we want to find is k, so we divide both sides by 13, both sides by 13. So we'll clear this off. So your final answer is going to be k equals the ln of 0.8125 divided by 13. And when you punch your calculator for that, what you would obtain is going to be negative 0.01597. You can confirm these answers with your calculator. So now we know our value of k, which is that. So you're going to make the substitution back here. So what we have here now becomes u of t equals, now my t, which is 33, plus my u naught, which is 81, that's 81 minus 33, then e to the power k. So the k I obtained below is this. So I'm going to make the substitution there, which is negative 0.01597. Then my t, which is t here. Now this is now the standard, this is the standard equation. Or you can just simplify it further by saying u of t equals 33 plus 81 minus 33. That's going to give you 48 e to the power negative 0.01597 t. So what the question says is find t when u is 60 degrees Fahrenheit. So when u is 60 degrees Fahrenheit, I want to find t. So I'm going to make the substitution. So I've been told that my u equals 60. So when I make the substitution here, you have 60 equals 33 plus 48 e to the power negative 0.01597 t. So this is the only unknown. So let's begin to do it step by step. So we can bring 33 here, it becomes 60 negative 33 equals 48 e to the power negative 0.01597 t. So 60 minus 33 is going to give us 27 equals 48 e to the power negative 0.01597 t. Yeah. Alright, since we know that, we could rewrite this as 48. So just bringing this laterally inversing the equation, e to the power negative 0.01597 0.1597. Then you have t equals 27. So we want to solve for t. So this is the first barrier here. So I'm going to divide by 4/8 to clear that out. So by 4/8, so this goes off. So what you're going to be left with is e to the power negative 0.01597 t equals 27 divided by 48 is 0.5625. So to find t, like we've been doing before, you take the natural log of both sides. So the lane of both sides is going to be the lane of this and the lane of this. So the lane of this automatically makes the power to become the coefficient. So what you're going to have is, so I'm going to write this here. So this becomes negative 0.01597 t. Then the lane of E equals the lane of 0.5625. So this goes to 1 like we know. So we are left with is negative 0.01597. Then we want to find t. So this equals the lane of 0.5625. So to find t, I'll divide both sides by negative 0.01597 divided by negative 0.01597. So this goes off. And then your t is going to be this divided by this. So which is going to give you 36.027. So but then what units are we going to use here? So it says to the nearest whole minute. So to the nearest whole minute. So it's a minute. So we're going to write that to the nearest whole minute. So to the nearest whole minute in whole number. So this is what we need. We need this. So since what we have here is less than 5, so our final answer is going to be 36 minutes. So this is your final solution.